In this video, we will go for numerical. In slider crank mechanism, the length of crank and connecting rod is given. Length of crank is 200 mm and length of connecting rod is 800 mm. Locate all the eye centers of the mechanism for the position of the crank when it has turned 30 degree from the inner dead center. ICR, that is Instantaneous Center of Rotation, is also known as I center, that is instant center. Means we have to locate all ICRs when crank has turned 30 degree from the IDC. We have to also find velocity of the slider and angular velocity of the connecting rod if the crank rotates at 40 radians per second. Configuration diagram of mechanism is shown. Length OA is representing crank, length AB is representing connecting rod, and at the end of connecting rod there is a slider. Angle made by crank with IDC is 30 degree. All dimensions are in mm, that is crank is 200 mm in length and connecting rod is 800 mm in length. First we will draw configuration diagram. To draw configuration diagram we will take suitable scale. We can take scale in the format 1:4, means whatever configuration diagram we will draw, it will be 4 times smaller than actual size. Means 200 mm length will become 50 mm and 800 mm length will become 800 divided by 4, that is 200 mm. Or we can take scale in the format 1 centimeter is equal to 40 mm, means for crank OA we should take length as 5 centimeter. Because scale is 1 centimeter is equal to 40 mm. Therefore, to represent 200 mm, we should draw a line of 200 divided by 40 centimeter, that is 5 centimeter. Similarly, for connecting rod AB, length will be 20 centimeter as 800 divided by 40 will be equal to 20 centimeter. We can prefer any system of scale. Now we will draw configuration diagram. Draw a line which will represent line of action of slider. On that line mark point O. Now draw faint line at 30 degree to the line of action. On this line mark point A. OA is 200 mm. According to scale, 1 centimeter is equal to 40 mm. Therefore, OA will be equal to 5 centimeter in configuration diagram. Now to mark point B in rounder, take distance equal to 20 centimeter. As scale is 1 centimeter is equal to 40 mm, therefore AB will be equal to 20 centimeter. Draw arc with center as A. That arc will intersect line of action and that intersection point will be B. Now we will draw fixed link and slider. Now we will give number to links. Fixed link will be link number 1. Crank OA is link number 2. Connecting rod AB is link number 3 and slider is link number 4. Hence, number of links in slider crank mechanism is 4. Therefore, number of ICRs will be given by relation n is equal to n into n minus 1 divided by 2. Therefore, n is equal to 4 into 4 minus 1 divided by 2, which will be equal to 6. Therefore, n is equal to 6. Hence, number of ICRs will be 6. Now we will write this 6 ICRs. As there are 4 links, in first row we will write link 1, 2, 3 and 4. In next row we will write ICR I12. Next ICR will be I23 and next ICR will be I34. In next row we will write ICR I13 and next ICR will be I24. In last row we will have ICR I14. Draw circle with any radius. On the circumference of that circle, mark 4 points 1, 2, 3, and 4. These 4 points are representing 4 links of mechanism. Now we will locate those ICRs which we can locate just by observation. Between link number 1 and 2, there is a turning pair at point O, hence ICR I12 will be at point O. As I12 is located, in circle diagram we will draw line joining point 1 and 2. This line in circle diagram is representing ICR I12. Between link number 2 and 3, there is a turning pair at point A, hence ICR I23 will be at point A. As I23 is located, in circle diagram draw line joining point 2 and 3. This line in circle diagram is representing ICR I23. Between link number 3 and 4, there is a turning pair at point B. Hence, ICR I34 will be at point B. As I34 is located in circle diagram, draw line joining point 3 and 4. This line in circle diagram is representing ICR I34. Link number 4 is a slider. Between link number 1 and 4, there is a sliding pair. Line of action or line of motion of slider is horizontal line. Hence, ICR I14 for relative motion between link number 1 and 4 will be on line perpendicular to line of action or line of motion, and it will be at infinity on that line. As line of action or line of motion of slider is horizontal line, therefore ICR I14 will be at infinity on vertical line. Hence, vertical line is drawn passing through point B, or we can draw vertical line anywhere on screen, and on that vertical line we will have ICR I14 at infinity. As we know, ICR I14 is at infinity on vertical line. In circle diagram, draw line joining point 1 and 4. Here you can notice line is not drawn between point 1 and 3 in circle diagram because I13 is not located yet. Similarly, line is not drawn between point 2 and 4 in circle diagram because ICR I24 is not located yet. Now, to locate I13 in circle diagram, find two triangles with 1, 3 as a common side. In circle diagram, two triangles with 1, 3 as a common side are triangle 1, 2, 3 and triangle 1, 3, 4. Now we will focus on triangle 1, 2, 3. In triangle 1, 2, 3, link 1, link 2 and link 3 is involved. For this 3 links, possible ICRs or possible combination of two bodies or links will be 3. That is I12, I23 and I13. Out of these 3 ICRs, that is I12, I23 and I13, I13 is already written. Hence, we will write remaining 2 ICRs, that is I12 and I23. Now we will focus on other triangle 134. In triangle 134, link 1, link 3 and link 4 is involved. For these 3 links, possible ICRs or possible combination of two bodies or links will be 3. That is I13, I34 and I14. Out of these 3 ICRs, that is I13, I34 and I14, I13 is already written. Hence, we will write remaining 2 ICRs, that is I34 and I14. Draw a line passing through I12 and I23. Now draw line passing through I34 and I14. But how to draw it, as I14 is at infinity on vertical line? To draw a line passing through I34 and I14, draw a vertical line through point I34, and on this vertical line I14 will be at infinity. Hence, it means we have drawn line passing through I34 and I14. This line is already drawn. We have drawn line passing through I12 and I23. We have also drawn line passing through I34 and I14. At the intersection of these two lines, we will have ICR I13. As I13 is located in circle diagram, draw a line joining 1 and 3. This line in circle diagram will represent ICR I13. On this line, write Roman digit 1. Now to locate ICR I24, in circle diagram, find two triangles with 2, 4 as a common side. In circle diagram, two triangles with 2, 4 as a common side are triangle 1, 2, 4 and triangle 2, 3, 4. Now we will focus on triangle 1 to 4. In triangle 1 to 4, link 1, link 2 and link 4 is involved. For these 3 links, possible ICRs or possible combination of two bodies or links will be 3. That is I12, I24 and I14. Out of these 3 ICRs, that is I12, I24 and I14, I24 is already written. Hence, we will write remaining 2 ICRs, that is I12 and I14. Now we will focus on other triangle 2, 3, 4. In triangle 2, 3, 4, link 2, link 3 and link 4 is involved. For these 3 links, possible ICRs or possible combination of two bodies or links will be 3. That is I23, I34 and I24. Out of these 3 ICRs, that is I23, I34 and I24, I24 is already written, hence we will write remaining two ICRs, that is I23 and I34. Draw line passing through I12 and I14. But how to draw it? As I14 is at infinity on vertical line, to draw a line passing through I12 and I14, draw vertical line passing through point I12, and on this vertical line I14 will be at infinity. Hence it means we have drawn line passing through I12 and I14. As I14 is at infinity on vertical line, we can draw vertical line anywhere on screen, and on that vertical line we will have ICR I14 at infinity. As in front of infinity, small distances or any distance which we can measure will not matter. Draw vertical line passing through point I12, and on this vertical line I14 will be at infinity. Hence it means we have drawn line passing through I12 and I14. Draw a line passing through I23 and I34. At the intersection of these two lines, we will have ICR I24. As I24 is located in circle diagram, draw line joining 2 and 4. This line in circle diagram will represent ICR I24. On this line, write Roman digit 2 as it is located after I13. All 6 ICRs are located. In numerical, given data is angular velocity of crank and it is 40 radians per second. Crank is link number 2, hence we can write given data as omega 2 is equal to 40 radians per second. We have to find velocity of slider, that is V slider, and angular velocity of connecting rod, that is omega 3, as connecting rod is link number 3. Now to find omega 3, according to angular velocity ratio theorem, we can write omega 3 divided by omega 2 is equal to distance between ICR I12 I23 divided by distance between ICR I13 I23. Omega 2 is 40 radians per second. In configuration diagram, we can measure distance between ICR I12 and I23. That is, I12 I23 is equal to 5 centimeter. We can also measure distance between ICR I13 and I23. That is, I13 I23 is equal to 22.9 centimeter. Therefore, omega 3 is equal to 5 into 40 divided by 22.9. Whatever distances we have measured, that is distance between I12 and I23 and distance between ICR I13 and I23. These are scaled distances. There is no need to convert these distances into actual distances, because even if we will do it, ratio of the distance will remain same. Therefore, omega 3 is equal to 5 into 40 divided by 22.9. It implies that if we'll go for this calculation, we will aim with a number omega 3 is equal to 8.73 radians per second. Now we will find velocity of slider, that is v slider. Slider is link number 4, hence link 4 will come into the picture. Fixed link is link number 1, therefore link 1 will come into the picture and it will act as a reference. To find v slider, that is velocity of slider, we will use basic relation v is equal to r omega. If omega 2 is used to find velocity of slider, then link 2 will come into the picture. Therefore, v slider will be equal to, we will have distance in bracket and it will be multiplied by omega 2. In bracket, we will have distance between two ICRs which will act as a radius. As omega 2 is taken, hence we should focus on link 2. Link 2 will have pure rotational motion about ICR I12. Link 2 will have pure rotational motion relative to fixed link 1 about ICR I12. Hence, first term in bracket will be I12 and next term in bracket will be I24. At I24, relative velocity or relative motion between link 2 and 4 will be 0. Hence, I24 can lie either on body 2 or body 4, and still at I24, velocity will be same as relative velocity or relative motion between link 2 and 4 will be 0 at ICR I24. Hence, we will have relation v slider or velocity of slider is equal to I12 I24, that is the distance between I12 and I24, multiplied by omega 2. If you are not comfortable with this relation, then we can go for analogy to understand it. On screen there are two blocks, one is of red color and another one is of green color. Assume that these two blocks are representing two bikes. Red block is bike number 2 and green block is bike number 4. Both bikes are moving towards right side. Bike number 2 is moving with a speed of 60 km per hour. Bike number 4 is also moving at a speed of 60 km per hour. It means relative velocity between bike number 2 and 4 will be 0, as both bikes are moving at the same speed. Now let us say we are having information that relative velocity between bike number 2 and 4 is 0. If speed of bike number 2 is 40 km per hour, then what will be speed for bike number 4? As relative velocity or motion between bike number 2 and 4 is 0, therefore speed or velocity of bike number 4 will be same as bike number 2. Hence, bike number 4 will move with a speed of 40 km per hour. Same thinking is applied to obtain velocity of slider, but how? Slider is link number 4 and crank is link number 2. Okay, now wait. Don't jump to the conclusion that link 4 and link 2 is having same speed, because that is not the correct conclusion. Crank is rotating with angular velocity omega 2 about ICR I12. Hence, I12 is the center of rotation for link number 2 relative to fixed link. ICR I24 can lie either on body 2 or body 4, as at ICR I24 relative velocity between 2 and 4 will be 0. Now here we are applying analogy of moving bikes. At I24, relative velocity or relative motion between link 2 and 4 will be 0. Hence, I24 can lie either on body 2 or body 4, and still at I24 velocity will be same for body 2 and 4, as relative velocity or relative motion between link 2 and 4 will be 0 at ICR I24. If I24 will lie on body 2, then velocity of slider, which is link number 4, will be given by relation V slider, or velocity of slider is equal to I12 I24 multiplied by omega 2. Now we will find velocity of slider. V slider or velocity of slider is given by relation I12 I24 into omega 2. We will measure distance between ICR I12 and I24. That distance is 3.1 centimeter. Now we will multiply it by scale. Now why we should multiply it by scale? As we are finding velocity, 3.1 centimeter is the scaled distance. Actual distance will be different. To get actual distance, we should multiply it by scale, and our scale is 1 centimeter is equal to 40 mm. We have measured distance between I12 and I24. That distance is 3.1 centimeters. So we will multiply it by scale. So that's why we are multiplying 3.1 centimeter by 40, and we will get actual distance between ICR I12 and I24, and it will be multiplied by omega 2. Omega 2 is 40 radians per second. If we will go for this calculation, we will end with a number 4960, and that will be velocity of slider, and its unit will be mm per second, because that distance I12 I24 will be in mm. As we are multiplying it by scale, we are getting that distance in mm, and we are multiplying that entire distance by omega 2, which is in radians per second. That's why we will get velocity of slider as 4960 in millimeter or mm per second. We can convert it to meter per second, and velocity of slider will be equal to 4.96 meter per second. Now we will find velocity of slider, that is V slider, by another method. Slider is link number 4, hence link 4 will come into the picture. Fixed link is link number 1, therefore link 1 will come into the picture, and it will act as a reference. To find velocity of slider, we will use basic relation V is equal to R omega. If omega 3 is used to find velocity of slider, then link 3 will come into the picture, and we'll have relation velocity of slider is equal to, we'll have bracket, in that bracket we'll have distance, and it will be multiplied by omega 3. In bracket we will have distance between two ICRs, which will act as a radius. As omega 3 is taken, hence we should focus on link 3. Link 3 will have pure rotational motion about ICR I13. That is, link 3 will have pure rotational motion relative to fixed link 1 about ICR I13. Hence, first term in bracket will be ICR I13, and next term in bracket will be ICR I34. At I34, relative velocity or relative motion between link 3 and 4 will be 0. Hence, I34 can lie either on body 3 or body 4, and still at I34 velocity will be same, as relative velocity or relative motion between link 3 and 4 will be 0 at ICR I34. Now we will find velocity of slider by using relation V slider is equal to distance between I13 I34 multiplied by omega 3. If you will measure distance between ICR I13 and I34, we will get that distance as 13.8 centimeter. we should multiply it by scale, because 13.8 centimeter is the scaled distance, it is not actual distance. So to get actual distance we should multiply 13.8 by 40, because 1 centimeter is equal to 40 mm. So we will get distance between I13 and I34 in mm if we will multiply 13.8 by 40. Okay, and we should multiply that distance by omega 3, and omega 3 is 8.73. If we will perform this calculation, then we will end with a number 4818.96, and obviously that velocity will be in millimeter per second. Okay, and we can even express it in terms of meter per second, and velocity of slider will be 4.81 meters per second. Okay,